name is Dr. Abby Turna, and I am the Waterkeeper and Executive Director for Suncoast Waterkeeper. So thanks again for being here. While I'm here and welcoming you, I'd like to go ahead and thank METV for being here to record us, and I'd like to thank the Bradenton Women's Club for allowing us to be here. And I hear there's, yes, let's give them a round of applause. Thank you. So I'm going to start with our mission of Suncoast Waterkeeper, so we're all on the same page about what we do. Then I'm going to talk about just really briefly what is a wetland and the values of wetlands, really super brief, because I think our panelists are going to do a great job of that. I'm also going to talk about what's at stake here with the comprehensive plan amendment changes, and I'm going to introduce our panelists. There's 3 panelists today, each of which are going to have 15 minutes to present their topic, and then at the end, we will be taking questions. But if you have the burning need to write down your question, that's great, because over there we have Peggy. Thank you, Peggy. She has cards and clipboards and pencils. You may go ahead and just take one and bring it back to your seat if you know you're going to have to write down some questions. And then we just ask that you deposit them into one of those cylinders so that I can pick them up at the end and make sure that your question gets asked. We'll have a lot of time for questions and answers at the end. I want to thank our panelists for being here. I'm going to give them a formal introduction in just a minute. So the mission of Suncoast Waterkeeper. Suncoast Waterkeeper is a nonprofit organization with the mission to protect and restore Florida Suncoast waters for the benefit of all through community and stakeholder engagement. That's what we're doing here tonight, right? We have stakeholders and you, the community, who are being engaged on this important issue of the value of wetlands. We also do advocacy, which we'll be doing on October 5th. If you don't have a card, October 5th is the Board of County Commission meeting where we're going to stand up and have our voice heard over this issue. And then we also do a lot of environmental monitoring. I'm happy to go into more detail about that at another time. And then when all of that is not doing the job of getting us to restore or protect our waters, we also take responsible legal action under the Clean Water Act. All right, so we're all here because we love wetlands. All right, you might not love wetlands, but I certainly do. I spent countless years studying wetlands in school. I have a PhD in geography where I studied wetland hydrology across the landscape scale, which just means I looked at wetlands in a large area and saw how they're connected to downstream waters and to our health. So this is a wetland. This is a picture that I took in Myakka River State Park. Hopefully you all can see that. Can I get I see some head nods. Yes, nice. This is the quintessential wetland of our area. So if you were to come off a train in 1848 when Florida became a state, these things would be everywhere. And then in the wet season, they connect across the landscape, and then they discharge out to the Gulf. And so maybe some of them were full of trees, and some of them are full of these more herbaceous plants. But these wetlands are the majority of our landscape. Some scientists say it used to make up 70% of our landscape. The majority of these depressional wetlands have been developed. So that would be more of the western part of Sarasota and Manatee counties. And now what we're talking about really is the eastern part, where these wetlands really do still flourish. I guess I should say that wetlands do have a legal definition, and then they also have a scientific definition. And so let me just give you one of those definitions now, just to make sure we're all on the same page. You see this beautiful picture, but what makes a wetland is really 3 things, which is water, plants, and soil. You have to have water for a long enough time to make certain soils, called hydric soils, which then create certain plants called hydrophilic plants or water-loving plants. So you have water-loving plants, you have water-filled soils that create different chemistry, and then you have the water to make that all happen. And that's why they are called wetlands. But the scientists are going to go into more detail about just what these things do in our landscape. I wish I could go into vast amounts of time to tell you about the value of coastal wetlands, but luckily I've got 3 other panelists that are going to help me work with that. This National Oceanic and Atmospheric Administration's infographic really does a great job of boiling down the importance of coastal wetlands. And and looks at some of the impacts they make both on the economy and then also just in form of flood protection and then also resiliency from coastal storms. You can see for flood protection alone, 1.5 million gallons of flood water can be stored in just 1 acre of wetland. We're talking about thousands, if not millions of acres of wetlands out in eastern Manatee County. We are talking about 20% 20% reduction in storm destruction from these wetlands. So it's a reduction to your potential impact from storms just by having wetlands available to absorb floods and wave energy. We're also talking about $23 billion in annual coastal protection services that are provided by wetlands. That is a lot of money. And we haven't even gotten into a lot of the other values like fisheries habitat, whether it's commercial fish or sports fish or just recreational fishing. So what is at stake here? What are we talking about as far as the comprehensive plan? Basically, goal 3.3 of the comprehensive plan is goals and objectives, and the land development code are policies to meet those goals and objectives. So when you get rid of the goals or the objectives, then you have to change the policy accordingly. So goal 3.3, just read that. It's to protect, enhance, and maintain the natural flora and fauna of resources of Manatee County to aid in the filtration of contaminants, provide for preservation of native species for passive recreational and aesthetic enjoyment, and to provide a healthy environment for Manatee County residents and visitors. That's the goal. Look at all that red. That is the removal of the objectives underneath that goal. So you're basically stripping all the objectives to meet that goal. If you stripped all the objectives that went toward a goal, can you still meet the goal? And that's what we're going to be talking about tonight. So in summary, what else is at stake is this. You look at the wetlands map on the right. These are mapped hydric soils. So remember, that's one characteristic of a wetland. And what we're talking about is the elimination of the protection of all viable wetlands. So right now in the comprehensive plan, it says that, and in our land development code, the state protects a certain number of wetlands that meet their criteria, but Manatee County says we want to do more than that. We want to protect all wetlands that we deem viable, and they have a definition of viable. So they do actually more protection of wetlands in the state, but that's going to be eliminated with these changes. The other thing that's going to be eliminated, which I think this is a big one, is that there are these things called, you could see WO districts, which are watershed overlay districts. Now, these are tiny watersheds in which water courses go right into our drinking water. So they're all the land area that drain into a water course that goes right into our drinking water. And what the comprehensive plan says now is these water courses that go directly into our drinking water deserve more protection. Therefore, we're going to make sure that 50-foot or greater buffer is surrounding these water courses in this watershed overlay district. We have 3 of them across Manatee County, which include our drinking water source, if you're in Manatee County, which is Lake Manatee. If you're in Bradenton, it's the Evers Reservoir. And then if you get your drinking water from the Peace River, there's also a little piece of Peace River, a watershed overlay district. So those deserve special protection. That would be eliminated. And in the state of Florida, no buffers need to be around water courses. Therefore, development can go right up to these water courses, which lead directly into our drinking water. And we think that's a bad idea. Finally, you would reduce buffers from greater of 50 feet to a minimum of 15 feet and on average 25 feet for all outstanding Florida waters, OFWs, and aquatic preserves. So you can see outstanding Florida waters are circled on the map in purple. What you see is really all of the bays at the coast and then the Myakka River are deemed outstanding Florida waters, which again, the comprehensive plan says these need special protection. We need wider buffers to protect these areas because these are important. Plus, when we're talking about aquatic preserves, that is money that the county has spent or got grants to preserve land, and they want to protect that asset. So that is what's at stake. Thank you so much to the panelists who came here today. They're each going to get 15 minutes to talk about their topic. First, we're going to have Ed Sherwood. Ed is the Executive Director of Tampa Bay Estuary Program. He became the executive director in 2018 after serving as the program scientist since 2008. Ed is responsible for maintaining the estuary program's strong interlocal partnership and continuing the base science-based restoration and recovery strategies. He directs Tampa Bay Estuaries Program technical and public outreach initiatives and serves as the primary policy liaison between its many public and private partners. Ed holds a BS in, that's a Bachelor of Science, he's not full of BS, a BS in Marine Biology from the University of West Florida, an MS degree, or Master's of Science, in Marine Fisheries and Ecology from the University of Florida, and in his spare time, he enjoys boating and on the bay and traveling with his wife and kids. Thank you, Ed, for being here. Next, we'll have Dr. A.J. Reisinger. He is an assistant professor of urban soil and water quality within UF-IFAS Department of Soil, Water, and Ecosystem Sciences. He is the state extension specialist affiliated with the Center for Land Use Efficiency, Program for Resource-Efficient Communities, and a member of the Sustainability, Human, and Ecological Development Group. Man, UF loves these really long titles. It was hard working there and saying your title over and over again. He is an urban ecologist and biogeochemist focused on how what we do on the landscape affect what flows downstream, which is why he's perfect to be here today. Dr. Reisinger received a Bachelor of Science in Environmental Science from Notre Dame, a master's degree in biology from Kansas State, and a PhD in biology from the University of Notre Dame. Welcome, Dr. Reisinger. Last but certainly not least, we have Mr. Jim Bays. He's the president of Steward of Our Urban Lakes, or SOUL, which is a nonprofit organization focused on community-based restoration and shoreline wetlands and lake water quality. Jim completed his Bachelor of Science in Environmental Biology from Ohio University and his Master's in Science in Environmental Engineering Sciences from the University of Florida. Jim has been a resident since 1978 and retired just last year after a 46-year career in wetland consulting, where he specialized in hydrologic assessment of wetlands and the creation and enhancement of wetlands for water quality improvements and habitat protections. Jim is certified as a professional wetland scientist and has completed many award-winning wetland projects throughout the United States. He's going to talk about some of those tonight. But he's also done award-winning wetland projects in Canada, Ireland, Italy, Singapore, Malaysia, India. So he's been around the world and knows what's important about wetlands. As a birder, Jim sees every wetland project as an opportunity to educate the public and to create, manage, and improve wildlife habitat. Thank you so much for being here, Mr. Bays. All right, so we'd like to get Mr. Ed Sherwood up here first. Thank you so much.
Okay. Good evening, everyone. Appreciate the opportunity to come speak to you tonight about the importance of wetlands. So I'm Ed Sherwood. I'm the director of the Tampa Bay Estuary Program. We're one of 28 national estuary programs established by Congress as estuaries of national significance. And we started back in the 1990s with restoration goals pretty much centered around seagrasses, but I'll be talking a little bit more about how we've expanded those goals to other important habitats throughout the Tampa Bay watershed. I realize that probably not everyone can see the slides, so I'm going to do my best to kind of walk through the slides and explain them as I go. So, we're interested in protecting wetlands because, our estuary is continuing to be urbanized. We only have about 32% of the natural lands undeveloped in the watershed. As Abby mentioned, we've already lost a lot of wetlands and other habitats that are key to fish and wildlife function and serve as important nursery habitats for a lot of important species that make our Tampa Bay estuary special. And we're projected to continue that increase in development in the watershed. By mid-century, there's anywhere from about 5 to 7 million people expected to live, work, and play in and around the Tampa Bay estuary. That watershed boundary that's highlighted there on the colored map on the right. So all those red areas are basically developed, suburban developed areas. The yellow areas are agriculture, and the purple areas are mining lands. So the remaining green areas are those undeveloped lands, the natural lands that still present an opportunity to continue to restore some of these key habitats. And that has been the history of the estuary program since our inception, moving from seagrasses slowly upslope into the watershed. Starting back in the mid-1990s, we developed our first restoration plan for emergent tidal wetlands, namely mangroves, salt marsh, and salt barren habitats. And that was called Restoring the Balance. That basically took the approach that there was this massive development in the watershed, so what we were going to try to do is get back the proportion of those important habitats back to a benchmark period back in the 1950s. With each successive update of that restoration plan, we actually included more consideration of more habitats, and we basically looked at future challenges as it relates to sea level rise, climate change, as well as continuing development in the watershed. So our latest iteration in 2020 basically takes all key habitats going from artificial reefs to oyster beds to seagrasses to tidal flats to marshes, mangroves, salt barren, all the way up to freshwater wetlands and coastal uplands. So we have developed now these benchmark goals and targets for the region for each of one of those key habitats, both at the 2030 time step and the 2050 time step. And the way we did it was basically looking at where restoration opportunities still exist within the watershed. So took a first blush at those land uses that haven't been developed, overlaid where protected areas currently exist within the watershed, but also look at opportunities where development hasn't occurred but is still in private ownership so that we could develop public and private partnerships to potentially restore some of those lands as well. And then overlay that with the hydric soils indicators that Abby was mentioning, as well as salinity conditions that we're anticipating into the future. When you bring all that map data together, you could basically map the known opportunities where habitat restoration can occur in the watershed. And to a certain extent, there's good news. When we went through that mapping exercise, there's still about 450,000 acres of restorable lands throughout the Tampa Bay watershed. Of that, there's about 209,000, about half of those that are acceptable to the key habitats that we've identified targets and goals for. So on the bottom left is basically goals that we've established both for the 2030 and 2050 time period. We're looking to try to gain back about 3,000 acres of all those different habitats by 2030 and a total of 10,000 more by the 2050 timeframe. And again, we've established those benchmarks across the suite of different habitats. And that's important because when we know where the restoration opportunities exist and we overlay sort of the potential of those different opportunities to become specific habitats, we could identify where our highest vulnerabilities are. And when we look at those 2050 targets, we actually don't have enough restoration opportunities in the watershed to get back some of the total intertidal wetland habitat that we've identified for our targets. There's not enough space. A lot of it's already been developed and those opportunities don't exist. So we need to do our best as it stands right now to protect what we have existing native habitats while also looking for new and novel ways to expand our opportunities into spaces we haven't considered in the past. And the graphic on the right is kind of highlighting that, where we're looking at non-traditional land uses to increase our restoration opportunities in the future. Again, working with public and private partners to hopefully get us there. And of course, for some of our key habitats, we're actually going backwards. We actually lost a significant amount of seagrass habitat in the bay over the 2016 to 2022 time period. So this creates an even higher imperative to start restoring these habitats because we're starting to lose traction on just maintaining those certain amount of habitats in the bay itself. And the good news is we've had a lot of will, we've had a lot of investment throughout the region to do these restoration projects. Going back all the way to the 1970s, we could count about a little over 750 discrete projects that have tried to restore some of these key habitats. And a lot of those projects picked some of the low-hanging fruit, so larger properties where we could do some fairly significant restoration. We don't have those low-hanging fruit anymore. So the restoration opportunities are becoming more difficult as the smaller in size and the more developed and patchwork of land that still exists in the watershed. So it's taking a lot more effort, it's taking a lot more investment to find those restoration opportunities. That's why I'm kind of highlighting why it's imperative that we need to continue down this path of making these investments. We can't stop, we can't rest our laurels on some of the past work that we've done. We've got to continue these investments if we want to maintain the quality of life, the habitats that make our Tampa Bay estuary special. And we have made progress, as I mentioned, even since when we developed the 2020 targets and goals for the out years. We've actually made some incremental progress on a couple of key habitats. So that's highlighted by those orange boxes adding on to the blue bars there. But we're trying to meet that dashed line by the 2030 timeframe. So there's still a significant amount of acreage that we need to try to accomplish for a variety of key habitats. And as I mentioned, a lot of what's going on in the watershed, the development that's going on is sort of outpacing our ability to restore some of those habitats. So over the past 30-year time frame, we've actually lost about 180,000 acres of opportunity. So we've converted a lot of the restorable lands to developed lands. And that, again, is outpacing our ability to restore some of these key habitats. So really trying to highlight that we need to continue to make progress, need to continue to make investments towards restoring these key habitats, or else we're not going to have enough space left in the future. And the flow of each of the land uses from the 1990 to 2020 time period kind of highlights where those opportunities are being lost in the watershed. We've developed a lot of open science tools so you could hone in on the data. A lot of the links in my slides will take you to these key graphics, and they're interactive so you could actually see like the flow of different land uses over this past 30 years. As I mentioned, the ability for us to do this work, we're losing ground, so we're looking for novel opportunities to do that. One of the projects we're looking at now is working with a golf course to restore some of the habitats in and around areas that they're known to flood. So already trying to work with private industry, private landowners to enhance their habitat value of their properties and look at opportune ways to do that, especially for areas that are going to be known to be flooded in the future. So that has a benefit both for them as land managers, but also has a benefit in terms of nutrient attenuation, carbon sequestration, all these ecosystem services that Abby highlighted as sort of important characteristics of wetland habitats. And we know just from past experience that if we make these investments, it's good not only for the environment in the form of more fish and wildlife. We've done some studies at Robinson Preserve that indicates, there's a lot of tarpon, there's a lot more redfish, snook entering into these habitats that were once fallow farmland. So that both has an environmental benefit, and if you look at the numbers, it also has an economic benefit for the watershed. We just recently partnered with the Tampa Bay Regional Planning Council on an economic valuation of Tampa Bay. And basically that highlights that there's about $32.1 billion in annual economic output related to the estuary and the habitats contained therein, mostly in the form of key job sectors that the bay's workers depend on. And if you look at those ecosystem services in terms of carbon sequestration, nitrogen attenuation, as well as flood protection, it's close to about $1.7 billion in annual return to the economy, again, from lost and avoiding some of the, those ill effects of each one of those different parameters. And just in Manatee County alone, if you look at just the Manatee County line item in that table, there's about $70 million in flood protection benefits just from the wetlands represented in Manatee County. That's looking over a 30-year period and about 1% storm return. So again, there's both environmental and intrinsic economic value to these habitats, to the local economy, and our protections as an urbanized estuary along the coast. And last but not least, I think there's also some highlights that Abby mentioned. Protecting these habitats also has been key to our regional resiliency strategies of how we're going to live and persist on the coast in harmony with our environment in the future. So again, all these ecosystem services and the benefits that we derive as human beings are key to us living resiliently and sustainably in the Tampa Bay region for years to come. So their protection is paramount, and that's basically my take home at the end of this slide is we need to protect our existing native habitats. We have developed aggressive restoration strategies for the future because of the challenges we're now facing with losing restoration opportunities, as well as the pressures that are going to come in the future with the coastal squeeze that we anticipate both from the seaward side as well as the landward side of our region. And I wanted to highlight going through this exercise of developing some of these key goals, the opportunities are there to restore these habitats. It just takes the will to make the investments and continue to make those investments. And if we don't invest now and capitalize sort of on the returns that those investments make in the form of fish and wildlife and of key sport fish in the region, then we're just going to pay for it later down the line. So I'll leave it there. I don't know if we have time for questions or you want to wait for the end, but.
Don't forget this question card.
Yep.
Thank you.
So thank you. I think AJ is next.
Okay, this is weird because, yeah, I see what I see and you see kind of what I see, which is fine. So my name's AJ. I'm not going to go through all of my titles again because Abby already kind of bored you to death with those, but I am a stream, river, wetland, pond ecologist. And like Abby said, my favorite way to describe what I do is I study how the things that we do on the land affect what flows downstream and how that impacts our natural resources and natural services that are provided by our freshwater habitats. One of the main things that we do on the land here in Florida that affects what flows downstream is urbanization. Urban developments change the runoff of water, of rainwater, as it flows across the land into our water bodies. And so it's a big deal figuring out how to deal with that stormwater runoff and modify our development practices in order to reduce those impacts of urbanization. And I think stormwater is super interesting because it's actually, if you think about it, maybe the first human impact on the environment. The first time that one of our ancestors decided to put a leaf over their head when it was raining so that they could sleep, they were altering stormwater runoff. So we've been changing how water interacts with the land for a very long time. And we're still trying to figure out how to reduce our impacts and kind of protect our downstream ecosystems. Increasing urbanization is known to lead to an increase in the flashiness of our hydrographs. What that means is that you get really high flows, really rapid increases in water levels, and then really rapid declines in water levels. That's because when rain falls on a parking lot, it can't go into the ground. It can't go down into the groundwater into these slow flow paths. Instead, it just moves right across the street into your gutter. That gutter pipes it to your stormwater pond or not, or directly to your stream. And that's why all that water moves a lot more quickly than it would naturally. And along with that flashy hydrograph, that water moving really fast across the land, that means there's not as many opportunities for some of the chemicals and pollutants that are on the land washing away to be removed or to be slowed down. So that leads to more pollutants loading into our freshwater ecosystems. It also means by us plumbing the landscape and installing stormwater pipes, installing drains, installing ponds, that changes how our aquatic environments are connected, and so that can affect how organisms move across the landscape, things like migrating waterfowl or fish or macroinvertebrates that might emerge from aquatic environments. Stormwater ponds are one of, if not the most important tools in a stormwater engineer's toolbox. This study here, you probably can't really see it very well, but there's a table with a bunch of different stormwater control measures. A study surveyed stormwater engineers across the entire United States and asked them what the most important and most commonly used thing that they have in their repertoire is for stormwater control and protecting downstream. Stormwater wet ponds ranked #1, most important and most frequently used. We know that stormwater ponds are really good at flood control. They're kind of just holes in the ground that you can route water to, and so they slow it down. They do what they're supposed to do. They store that water before it moves downstream. They're also expected to provide pollutant removal services by removing things like nutrients and sediments and that sort of thing. And that we're not as clear on, and that's what I'm hoping to talk to you about today. Stormwater ponds are super important in Florida because they're everywhere. This on your left here, I hope you can see it, is a map of the state of Florida. There's a bunch of blue points on that map. It's not just blue blobs. It's actually about 76,000 individual stormwater ponds that we mapped on the state of Florida. We estimate that those 76,000 stormwater ponds take up more than 1% of the entire state's surface area. 1% isn't a huge number, but there's actually more of our land covered with stormwater ponds than industrial areas on the landscape. So these are completely artificial, completely engineered ecosystems, and we aren't really sure how effective they are at doing what we're hoping that they're doing for us. So that leads us to what we think they should be doing, what our expectations are. And some of our work, we're starting to find that the expectations differ depending on who you're talking to. So if you're thinking at a broad societal level, the kind of philosophical reason why we provide or why we build stormwater ponds, first, foremost, number one with a bullet is flood control. We want to protect downstream from flooding because massive catastrophic floods can lead to major human health issues, deaths, large infrastructure failures, that sort of thing. So flood control is super important. That's how they've always been designed, and that's the first and foremost priority. From a regulatory perspective, number two is water quality benefits. We expect stormwater ponds to capture and settle out sediments that are eroding off the landscape, to assimilate and remove nutrients before those nutrients get exported to downstream natural water bodies, and then to also accumulate other anthropogenic litter, which is what scientists like to call trash, and just prevent all of that kind of gunk from gumming up the works further downstream. I like to remind people that stormwater ponds are not built and designed to be pretty themselves. They're built to protect our natural environments downstream. Sometimes those two things can go hand in hand, but it's sometimes a hard point to get across, especially when you're talking to local residents who also agree flood control is super important for stormwater ponds. A colleague of mine, Paul Monahan, led this study where they surveyed local residents actually in Manatee County, primarily in Lakewood Ranch, and they asked what they expect their stormwater ponds to provide for them. Flood control is the top-ranked, most important thing. Great, awesome, we're all on board, we're all on the same page. Number two is increased property values. We want our ponds to make our homes worth more. I understand that. I understand that from a personal perspective. You often have to pay more to actually live on a stormwater pond, which is kind of surprising if you think about what it actually is, but that's what it is. Number two is open water views, and I think the main reason people expect those open water views is because open water views lead to increased property values. That's kind of our expectation. It all feeds back to money. I mean, I agree. I'm kind of broke right now. I could use some more money too. But then we want open water views, but we also want wildlife habitat. Wildlife really doesn't like open water views as much. They like plants, they like some habitat, they like some kind of messiness in the environment, but that's besides the point. Finally, the fifth ranked thing, homeowners do recognize that stormwater ponds can provide water quality benefits. Maybe not the top priority, but they're there, we're on the page. Cool. All right, so we have these expectations, but do they work? So for the rest of my however long I have left, I'm going to talk to you about a few different research studies that I've done, some of my colleagues have done, and some others have done as well. It's going to get a little sciencey. Hopefully I'll explain everything fairly well, but if not, you can ask me for details in the Q&A. The first thing I want to talk about is a study that actually a colleague of mine, Basil Iannone, and his master's student, Kayla, led looking at whether or not stormwater ponds protect urban wetlands. And so what they did is, and I was a part of the study too, so I guess I should say what we did is we went out to urban wetlands and we identified urban wetlands that had stormwater ponds upstream draining into them, and then other urban wetlands that had similar urban land use but no stormwater ponds. So there was some that were buffered by stormwater ponds, some that weren't. And then we also had some natural wetlands that didn't have any urbanization. We looked at how the water levels changed, how the hydrology changed, as well as how the sediment and water chemistry changed. We found there's no difference in urban wetlands or any of the wetlands with how fast water levels rose during the storm. So that's not great. There's not really that effect on hydrologic flashiness. Okay. But we did find that water level in the wetlands that had a stormwater pond upstream, so the urban wetlands with a stormwater pond, dried out, I guess, drawed down more slowly. So they're a little less flashy on the tail end. So that does say that those stormwater ponds are probably protecting the hydrology somewhat from that overall urbanization impact. So that's like a check plus, like kind of a B on the ranking maybe. I don't have an actual grade for these, but a little bit of support for that, for the hydrologic benefit. And then we did this the chemical analysis, and these plots on the right are kind of complicated. Basically what you need to know is green points are the reference non-urban wetlands, red points are the urban wetlands without a stormwater pond, blue have a stormwater pond. If the points are closer together, they're more similar. If they're further apart, they're less similar. You don't really even need to know anything about these plots because I'm going to tell you what they mean. What the first plot, looking at the soil chemistry, tells us is that wetlands draining stormwater ponds had similar soil chemistry to our natural wetlands, whereas urban wetlands without stormwater ponds had different soil chemistry. So stormwater ponds did protect that soil chemistry within the wetlands. So that's a benefit from the stormwater ponds. So that's a check on that scale. But from the water chemistry perspective, we did not find any difference between stormwater ponds in urban areas with or without wetlands. So stormwater ponds have some benefits maybe over the long term because soil chemistry might integrate those pollutants over a little bit longer of a time scale, but we weren't able to pick it up in the water, so there's some other mechanisms going on. Okay, so now we're getting into stormwater ponds. Stormwater ponds, like I said, are super important, super long-standing. They're everywhere, right? So if they're everywhere, we must know that they're working for us. Well, so these figures are actually from what I call the Stormwater Bible for the state of Florida. It's a Harper and Baker report to the Florida Department of Environmental Protection in 2007. And in this study, they did, it's like hundreds of pages long, but these two figures are really great. They did a review of the nitrogen and phosphorus removal efficiencies of stormwater ponds. We kind of expect stormwater ponds to remove about 80% of the nutrient load. And what we see here on the top figure, if you can see it, is looking at the percent of phosphorus being removed by wetlands. And on the bottom axis is how long water is held in those wetlands before it's discharged. And it goes from 0 to 600 days. So after about 100 to 200 days, those stormwater ponds are removing about 80% of the phosphorus that's coming in. So that's pretty good. They're doing about what we expect. Nitrogen, on the other hand, which is on the bottom, never gets above 50%. So the best that stormwater ponds do for nitrogen removal is 40 to 45%, even if you hold onto the water for almost 2 years. And we see similar results to this in other parts of the country as well. This is a study that I'm not going to ask you to really memorize or look too closely at this graph, but this is a study that was done before and after the construction of stormwater ponds in a developed area. They looked at a stream that was draining the development, and the light blue bars on the left are before and the dark blue bars on the right are after, and anything that's shaded out was not different. Basically what they found was that after the construction of stormwater ponds, there was an increase in algae in the streams, there was an increase in nitrate, there was an increase in organic nitrogen, and there was an increase in total suspended solids. So those are all the things that we're expecting these ponds to reduce, and they're actually, in this study, they were having a negative impact. They were increasing those values. They did do pretty good on phosphorus, though. You do see there's one decrease, the second to the right on the blue. That's phosphate. So they're still pretty good at phosphorus. That's great. So why aren't ponds more effective at removing nitrogen? I have spent the last 15 years of my life studying the nitrogen cycle. I know this diagram like the back of my hand. I don't expect you all to know this diagram at all, but this is just a diagram showing all of the different forms that nitrogen can be in. There's like 7 boxes on there, so those are all different forms, and all of those arrows are different biological processes that convert nitrogen in between those forms. And that's not removing, there's only one on there that's actually removing nitrogen from the system. The rest of them are just changing from inorganic form to organic to inorganic, or between, so it's very complicated, basically. And so we wanted to know, well, let's measure these complicated processes. That's why we don't know why ponds aren't good at nitrogen removal, because it's complicated. But if we want to know, we got to measure it. So that's what my lab has been doing a lot of lately. And this is a study, I'm just going to go ahead and jump ahead, looking at nitrogen removal, the permanent nitrogen removal process. It's called denitrification. And I had a master's student that looked at these denitrification rates from Gainesville ponds in blue and Miami ponds in orange. This is kind of a complicated figure, but on the left you see ambient. That is when there was no nitrogen. This is just background levels, no added nitrogen, just background levels from the ponds. We measured nitrogen removal. Not a lot going on, pretty much flat lines right at 0. Okay, then we did a simulated stormwater runoff event where we spiked these systems with nitrate. We added a little bit of nitrate to kind of prime them and see what would happen if there was stormwater coming in. And you see that all of them shift up, but especially in Gainesville, those Gainesville ponds get really good at removing nitrogen. And when we looked at those ponds, we're like, oh, the Gainesville ponds have a lot of plants. They have a lot of organic matter in their sediments. They haven't been dredged. They haven't been manicured. They're kind of a little bit more of a naturally developing pond. And so it seems like, and then the Miami ponds were manicured. They were turf grass to the edge. They were dredged regularly, basically just looked like white sand at the bottom. So we think that's what's happening, is that a lot of these nitrogen removal processes are being limited by management and also are being outcompeted by some of these non-removal processes like algae that are really good. Another thing that can happen in ponds or in any water body is that there's actually various algae and cyanobacteria that actually can produce nitrogen. They suck nitrogen out of the air and pump it into the water. That's called nitrogen fixation. So it's kind of the opposite of the nitrogen removal process of denitrification. And so I have another student, Audrey Geckner, who's been working on this actually here in the Bradenton, Lakewood Ranch area primarily. And she did a study where she measured nitrogen removal via denitrification and fixation or production, and measured that in 15 urban stormwater ponds and then 6 natural ponds and lakes. And she found, so looking at this figure, to the right of the red line is everything that had denitrification. So that's removing nitrogen from the system. That's a benefit for downstream water quality. Everything on the left, 40% was nitrogen fixation. That's actually meaning that the water is a source of nitrogen for downstream. So in addition to whatever nutrients are coming in from the landscape, the ponds themselves are adding even more. So 60% are denitrifying. That's better than 40%, I guess. So that's a good number. But then when you look at the difference between urban and natural systems, so the urban stormwater ponds are 50-50. Half of the ponds were net sources, half were net sinks. The natural areas, however, were the vast majority were net benefits for water quality, where 80% were removing nitrogen. So our urban stormwater ponds are not functioning at the same rate as the natural ponds that we found in this current study, at least. So do ponds protect downstream water quality? That's kind of what I wanted to focus on for this presentation. I mean, it kind of depends on what you're looking at, right? Ponds are good at some things. They're really good at flood control. They're pretty good at sediment removal. They're really good at phosphorus removal. A lot of those things are removed because the sediments and the phosphorus settle out of the water column and just kind of fall to the sediments. So that's great. Ponds are not so good at other things. They're not really good at nitrogen removal. They have mixed messages about algal control and downstream water quality. I could talk more about that, but I just didn't have time. And what we're finding now is that the internal biogeochemical processes and competition between algae and bacteria and removal and production, there's a lot of different things that are going on, and we need to figure out ways to optimize. Oh, I'm jumping ahead. As we learn more about the processes that are driving nutrient removal, we're working to figure out what's like kind of limiting the beneficial processes or maximizing the negative processes. And if we can figure out those drivers, then we can start to develop management strategies or design strategies to optimize the good and reduce the bad. So that Gainesville and Miami study, we found less manicured ponds had higher rates of denitrification. Maybe that means we need a little bit more organic matter in all of our ponds, but we also recognize that nitrogen removal is just one part of the story, so there's a lot of different things that need to be considered. We're also looking at the benefits of pond plantings, looking at littoral shelf plantings through FDEP funding and seeing how good plants are directly by themselves at sucking up nutrients before it makes its way downstream. And finally, I was down here also to start scouting sites for a new National Science Foundation funded project where we're now starting to look at how social perceptions of residents, communities, and regulators influence the management of ponds, and then how pond functioning influences those perceptions, so how they feed back on each other, and trying to develop ways to get everybody on the same page on what we want our ponds to do and how we can really maximize their benefits. So with that, I don't have time for questions, or I will take questions during the Q&A, and thanks a lot. And Jim is next, I believe.
Great talk. All right. Let's see if I can do this. Hey, everybody. Thanks very much. Can you hear me all right? Good? All right. First off, my topic is in addition to what you've heard here. You've heard about the wetlands. I'm largely going to talk about the area just outside the wetlands, the periphery, the perimeter, that may be preserved as a natural system, or it may be engineered or modified by people. But first I want to say something a little off topic, maybe a little unusual, and say I come from a future. That is, what am I talking about? I live in Pinellas County in St. Petersburg. It's a great place. It just got rated as one of the happiest places, right? But as a county, it's all developed, pretty much. All the counties that are not fully developed have opportunities to preserve and protect the remaining natural heritage that they have in the form of wetlands. Right now, my little company, Stewards of Urban Lakes, what we focus on is trying to claw back out of that urban setting some wetland projects, some restored habitat around lakes to provide some of the benefits that AJ has been showing there and that Ed showed so well. So you have an opportunity here, it looks like, to perhaps influence how that future goes. All right, let's see if I can make this work. Well, let's start with the basics here. Wetlands, we value them because they are the natural buffers on an existing ecological gradient. And what I mean by that, there's typically, the wetlands are occupying the lowest spot in the topography. Water flows downhill, and it carries with it the pollutants, it carries with it the propagules of plants, it carries with it the carbon from the watershed. It brings with it, and these within the wetlands themselves, there's an internal process of sedimentation, of particles being dropped out in the wetlands, transformations, just like AJ was showing there with the nitrogen, accumulation of phosphorus in plants, and that creates a habitat that then supports the biology and the diversity that we value here. So it's all already sort of a gradient to get there, to get to that point. That gradient has been recognized, though, as to include not just the wetlands itself, but the area around them. And the buffers themselves have been essentially recognized as providing valuable services almost as much as the wetlands themselves do. It's been shown that the wetlands are really, the intention of the need to protect the buffers is to minimize human activities and the disturbance to protect wetlands. I'll read this quote here. Buffer zones are natural or managed areas used to protect an ecosystem or critical area from adjacent land uses or sources of pollution. And as this one study showed 23 years ago, it's essential that terrestrial buffers be maintained maximally in the vicinity of wetlands, that there's a value in protecting them. So the buffers protect in multiple ways here. Essentially, the primary ways are what we've heard about so far: water quality protection, water traveling through the soils around a wetland or overland flow to a wetland are essentially flowing through areas that remove pollutants and provide opportunities to create habitat and support vegetation. Wetlands themselves to provide storage, you've seen that. That storage of water mitigates and potentially minimizes the effects of flooding or high rainfall and storm events, which we have so much of. They protect against erosion, filling the wetland. They essentially provide a physical buffer to movement of sand and sediments into the wetland. And they preserve a habitat. Not all wetland animals use just the wetland. They use the perimeter. You've seen turtles nesting in areas around ponds, birds going back and forth between the terrestrial perimeter and the wetlands themselves. You know that there's a biology that exists primarily because there is that upland area for nesting and resting. But there's other benefits to a buffer itself, what I call ancillary. That is typically not necessarily by design, but they have been noted to be beneficial. First off, any opportunity to grow plants and store carbon in that process of photosynthesis is an opportunity to mitigate the effects of climate change. So we have that intrinsically within the buffers around wetlands. There's an opportunity there for recreation and education. Often there's opportunities for trails or bird watching or just aesthetic enjoyment of the environment. It's a sustainable land use, and by that I mean it's preserving that area from further development, and it provides an opportunity to see the natural system in its original state. And a few more points here. It's a connection of wetlands by buffers, provides opportunities for wildlife corridors, and it's another wall, another barrier, if you will, for protecting the public health and safety from flooding and other water quality issues. So, so the wetlands themselves are really, as I mentioned, on this gradient, but there's different water enters and is processed through wetlands in different ways. You can have an overland flow where water flows over the surface of soils, and then may either go directly to the wetland or essentially may soak in and then emerge out of that flow, or a subsurface flow where it flows through the root zone and into the wetlands below the ground, or even percolate deeper than that and surfacing back into the wetlands. This function, this is widely recognized as an important feature of wetlands, because during our wet season here, when water tables are high, they can be essentially discharging wetlands that are filling and they're overflowing. But during dry seasons, drier spring and winter, they can actually become a source of water locally. And having that perimeter around a wetland provides an opportunity for that water to be used and to be a benefit to the environment. So water quality protection has been said many times, and it's understood, but essentially the process here is that it affects different kinds of pollutants in different ways. A buffer around a wetland will help capture larger particles, sediments and sands and things like that. And attached to those will be phosphorus, often in a particulate form, or it can be absorbed and attached to that particle. But dissolved phosphorus may simply just find its way through the soils themselves and be taken up by plants and converted into an organic form and stored and kept from the downstream waters. Nitrogen is more complicated, as AJ was saying, but that opportunity for that water moving through the buffer to encounter areas of organic carbon and low oxygen conditions can facilitate the removal of nitrogen through denitrification. But there's no one easy formula for all that. This process is affected by a lot of things: the slope of the buffer, the flow rate that's coming in, the type of soils. A number of factors make it difficult to actually predict exactly what that buffer will do. But people have tried, and there's been a number of studies over the last 30 years, mostly during my career, where people have really focused on the use of riparian buffer zones and the use of wetland buffer zones. This figure here shows the results of a very simple little search in the literature that I did prior to the talk, where I found over 3,000 references on the use of riparian buffer zones over the last 30 years, and over 200 references on wetlands. So there's no shortage of information about their potential benefit and why we should have them in our planning. The ability for buffers to function does vary by what function we're looking to study and optimize, and the width of the buffer. These figures here are a little complicated, but what I'm showing is that based on the literature studies, people have noted that a buffer width anywhere from 30 to 50 feet or more is needed to maintain and to achieve many of the functions that we're desiring to see to protect wetlands. That is nutrient removal, protecting habitat for wildlife, removing sediment, maintaining an aesthetic environment. There's no one number, but there's a range of numbers that have been developed over time. And the importance of that is that as we find ourselves looking at shrinking buffers, we're actually losing the opportunities that implied by the studies, but also just by our own observations and desires to protect the wetlands that are there. We're actually losing opportunities for protection. So it's not just of the functions that I'm speaking to specifically here, it's actually how they affect us in our social economy. And AJ clearly showed the benefit there, that very interesting couple slides there. But the thing we're trying to protect typically is water supplies, making sure we have clean, potable water. And to do that, we need to reduce the nutrient loading to surface waters when that's the primary source. Well, having wetlands and the buffers attached to them does reduce that potential cost of additional treatment required to achieve a good water quality for drinking. Wetlands, I mentioned several times now, the buffers help manage that flood protection function. We're all familiar with wetlands and the variation that we see seasonally here in Florida for our streams and our wetlands. At one level doesn't quite do it. You have to have a range for that water to be stored in during higher water periods. As was noted, property values are typically positively affected by being close to a conservation area or a buffer area around a wetland. That's been shown. And there's always an appreciation for the aesthetic values of having buffers around wetlands. So I wanted to talk about one project that I worked on over the years down in Naples in Collier County. It's called Freedom Park. And this is a case where the natural buffers that were adjacent to an existing stream course, the Gordon River, were replaced by development. And in order to restore some of that buffering effect and protect downstream waters in Naples Bay and the receiving water, they had to build a whole new stormwater pond system. And this is a 50-acre combination of ponds and wetlands and a restored natural cypress wetland. And the idea here is that the water is coming from a 900-acre watershed flowing through the pond and gradually working its way through these series of wetlands. The wetlands themselves provided a very good removal rate. First of all, let me say that this was an expensive project. It was over $30 million to build this, and that's one of the key take-home messages here, is that to replace the functions that we're removing through our development and our activities around wetlands, we are in fact probably, and I think it was said by Ed and by AJ, looking to spend more in the future to help manage our water quality. But this system here is very effective for phosphorus removal, over 80% reduction. For nitrogen removal, certainly around 39% or so when we studied it. And one of the issues with nitrogen reduction is that there are background levels of nitrogen that really, it's very difficult to get below. It's an organic form, it's natural, it becomes part of the background and feeds our estuaries where we actually need some organic nitrogen, but we don't really need the dissolved or inorganic forms. So wetlands are good at removing all that and improving the quality downstream. These kind of projects can be very valuable. They really show that what the benefits of a buffer in terms of the aesthetics, making sure people can use these sites for wildlife improvement, wildlife studies, appreciation. But the cost and the requirement for land is significant. This is pretty much the last bit of restorable land, like in using Ed's terminology, that was available in this location. And this is now part of the city's stormwater plan. So that's primarily what I've got. I've got a connection here to citations if you want to pursue this any further. But thanks for the opportunity to present. Okay.
So I got a lot of questions, you guys, and we're not going to be able to go through all of the questions, but I'm going to try to pull out some questions. And then at the end, where I'm going to leave a little bit of time because I know some of you wanted to ask your questions into the mic, and METV set up a microphone over here so that you can ask the question yourself and I don't have to read it. But I will let you know when that time is coming. So first, is there currently any plans for mitigation and conservation projects on the Manatee River? And Ed, I guess you would be the best one to answer that question.
Yeah, we actually have a Tampa Bay Environmental Restoration Fund project looking at upland and freshwater wetland restoration in the Lake Manatee portion of the watershed.
Okay, great. So stormwater ponds are not as good as natural wetlands in removing nutrients. Is that true?
I cannot say that for sure because we haven't really I personally have not done any work looking at wetland nitrogen removal or phosphorus removal. Our work looking at nitrogen cycling in natural lakes compared to stormwater ponds would suggest that is likely the case, but it's unclear from my perspective without actually getting out and measuring some of the wetland functioning.
Do you have anything to add, Jim?
Yeah, I'll speak to that. So ponds are structurally very different than wetlands. The ponds are the open water, so they grow algae and they don't grow the macrophytes that we require, that we really expect to see that is beneficial for uptake.
Macrophytes are plants.
Okay. Okay, yeah, okay. So I feel like I've got a subtitle going underneath me here, like one of those crawling chirons. What he's saying is, but they're different habitats. They have different functions, just like AJ said. And our observation is that In an urban context, there may not be a huge difference in how they function, but they can be made to be improved. They can be improved by the addition of a filtration wetland at the outfall end of a stormwater pond, or like in the example I showed at Freedom Park in Naples. If you attach a wetland to a pond, you will certainly get a better quality product, a better quality concentration coming out. And certainly the benefit of adding wetlands to a pond to kind of make that more of a mix is beneficial. So I hope that answers the question, but there can be an equivalence, but the wetlands they do operate differently.
I was just going to add to that and kind of build off of what AJ showed. I think there's some disturbing trends for some of our lake systems as well as some of our marine systems, that there's these algae that could fix nitrogen and create more nitrogen in those systems and then export those to coastal water bodies. And those are typically like blue-green algae or cyanobacteria. And those are bad things generally because they also can create some toxins. So if your system is out of balance and its propensity is to have these type of blooms, that doesn't do us any good water quality wise either. So thinking about how we could restore some of the semblance of nature in these systems is an important, I think, thing that was highlighted throughout everyone's talk, and that's what we should be focused on moving forward, of how we develop smartly in the region.
And thank you so much. I would like to add, while the question was about nutrients, that's not the only service wetlands provide. So the wetlands provide a vast number of services, which outweighs the number of services stormwater ponds provide. As part of the Healthy Pond Collaborative, we developed a guide that would help homeowners better manage their ponds so that we can get more function, similar but not close, but similar to the number of functions that wetlands provide. And really that's just by putting more plants in ponds, those wetland plants. What do you say? This one's going to be tough, guys. I don't even know the answer to this. But what do you say to people who do not believe in science to guide decision making?
I could start.
Okay, yeah, that'd be great. You work with a lot of different stakeholders.
So I think we live, work, and play in the Tampa Bay region because of the beauty that it possesses. You know, the certain aesthetics. You know, there's culture, community. Maintaining that in the future is, I think, top of everyone's mind, depending on your political affiliation or your beliefs. So, at the end of the day, I think we could have common conversations about protecting what makes Tampa Bay special. And moving forward, I think the community wants that. We just need to make sure that there's will to support that in the future.
Yeah, and I think scientists rightfully get a bad rap sometimes with our communication abilities, and I think that as a scientist, I need to do a better job meeting people where they are. And if you find what somebody's passionate about, what somebody cares about, and can figure out a way to tell them the story and how it affects them directly, I think that's a better way rather than blaming somebody for causing a problem. So I grew up on a small farm. I went to the local tavern a lot with my dad, and the farmers had their livelihoods. And when I started studying water quality, they all kind of started to hate me because they thought I was the bad guy. But then I talked to them about fishing and hunting and how water quality is important for that, and they realized that it's important too. So you just have to figure out the connection for whoever you're talking to, and that's a really good way to kind of reach people where they are.
I completely echo what AJ said there. What's the common thread you can form with that person? But if the question is, what do you say to a person who doesn't believe in using science for guidance, or the words to that effect, I would first ask them, well, what's your source of information that's guiding you? You know, how are you making your decisions? You know, and then I'd try to get in there in the conversation somewhere that there is a substantial amount of research, you know, objectively in the whole scientific process that they could look at, or we could make them more aware of. I really believe it's a matter of education and outreach for the most part, for the majority of those folks.
All right, awesome. Thank you. With studies showing that maximum buffers are what is best, then the reduction being proposed to buffer width will that also reduce wetland benefits?
Okay, so the question is, reducing buffer widths will reduce wetland benefits.
That's correct. That's correct.
Essentially. What I've tried to show is that science informs us that there's quite a range of functions provided by these buffers. Buffer widths have varied substantially in the studies that have been done. There is a general convergence that a range of buffer widths are beneficial at least minimally beneficial in terms of sediment reduction, nutrient reduction, hydrologic enhancements, flood mitigation. But they're all different, and they're all derived from studies that vary a lot in their setup. What's important to recognize is that any buffer is beneficial, but a reduction in a buffer is going to be a net reduction in that system. If you recognize the wetland and the buffer as a true ecological system, any reduction is going to have a negative effect in the long run, or at least be less beneficial than it is right now. So, and also my other thought on that is that in that reductions that would take place, those are hard to come back. Those are hard to restore. Once you've lost them, you're typically looking at a different landform, land development type in place of that, and that's very difficult to recover. I hope that answers the question.
Yeah, I think the only thing I'd add to that is towards the tail end, if we're talking about a buffer, I view it through the lens of a lost opportunity because of the characteristic changes that are going to come with that close association with development, and that opportunity for those habitats to migrate or to accommodate in the future becomes less. So again, I view it more of, if we're talking about a buffer width, no matter the width, we're already talking about a lost opportunity to restore some of those habitats.
Thank you. There's a lot of good questions here. Thank you so much for writing these down. What effect does wetland preservation have on drinking water? Can anyone answer that?
So wetland preservation protects drinking water supplies. In our area where you live in, a lot of our water comes from groundwater. Also, a fraction of it comes from surface water. It's different in different counties. If wetlands are maintained within the watershed, and this is the objective of many other cities in the country, such as New York City, where they have to protect their very pristine water quality to supply their large city. They require wetlands protection. They require wetlands buffers. The intent there is that that's one other natural form of defense against pollutant loading, contaminants, organic contaminants, the kind of pollutants that we're looking to keep from that would further affect the water quality in our drinking water supplies. From a groundwater perspective, wetlands have a very natural ability to remove nitrogen, and as the water trickles down through, the percolates to the bottom of a wetland and ultimately into our drinking water aquifers, those wetlands remove nitrogen and many other types of organic contaminants and pollutants. So wetland preservation is building into our ecosystem a protection for our drinking water supply. It's just that simple. How much we need depends on a lot of things, but the basic principle is that you're building in a protection.
Okay, he covered it. All right, great. Yes, perfect. Ed, this one's for you, and I think this is a really important question about kind of process. Does Tampa Bay Estuary Program ever advise policy board members like Manatee County on policy issues, like eliminating protections from the comp plan? So this is like a process question. I guess we don't understand the process maybe of how Tampa Bay Estuary Program interacts with the policy board. Could you go into that a little bit?
Yeah, each of the 4 county governments and 3 city governments have an elected official that sits on our policy board, and there's opportunity to brief on different issues at that point. We, as a program, develop regional guidance, goals, targets that I kind of explained during my presentation. It's really up to the governments at that point to either listen to those recommendations or go their own way. So we're not a regulatory body. We don't have any regulatory authority over each of the municipal governments. We work as a partnership organization, and hopefully by working together, we're all doing the right thing for the protection of Tampa Bay Estuary. And that's the way we kind of frame our discussions with each of our policy board members.
Okay, great. And there's a follow-up and just making sure that so on individual policy issues, the estuary program is not usually asked to weigh in or to give expert feedback or anything like that.
We specifically have a policy if it's permit related that we don't weigh in on those things, but we're always happy to provide guidance or scientific input on any topic that we're asked of by our policy board members.
Awesome. Thank you so much. All right. So there was a question about fish habitat because fish habitat wasn't really mentioned. Is there anyone here that can speak a little bit more on the values of fish habitat in stormwater ponds maybe and versus wetlands? There are some numbers and letters in here that I can't read, so I apologize to the question writer.
So why fish?
I think that was mine. What I was asking was there a difference between the ponds that you checked with fish or the ponds without fish? I'm a fisherman and I just want to more.
Well, yeah, no, I hear you. We have, so in our work looking at ponds, we have not gone out and measured, quantified the fish communities at all. We did the macroinvertebrates, but we didn't do anything looking at the fish. We didn't do any seining or shocking or anything like that. Anecdotally speaking, I would say that stormwater ponds are stocked pretty well by sometimes the people that sneak out in their backyards at night and want to pop in some more prize bass or something like that. We do have at UF, we have some really great fisheries scientists that have worked in stormwater ponds, like Chuck Sikra, who I can, if you're interested in more, I could reach out to him to find out. But I just anecdotally, I can't really say even beyond saying like there can be some big fish in those stormwater ponds, I guess.
It was because Manatee County is supposed to have a thing where they have to stock ponds over a certain size with a shelf.
Oh, interesting.
Every pond has to have a shelf.
Okay.
And so it breeds small fish, this bigger fish can hide underneath. And I just wondered if it would make any difference to water quality with the fish.
I mean, yeah, water quality, like, so the stormwater pond is a rough place for anything to live, kind of by design. They're built to be extreme. They're built to capture floods. They're built to filter out all those pollutants. And so certain fish taxa will be a little more sensitive. Some will be a little more tolerant. I think, like, we don't have cold water species here in Florida, so you don't have those kind of like brook trout or anything that you really have to worry about. I think the Florida fish are a little more resilient from my experience, but I can't say that for sure. I would imagine that water quality is going to be a concern, but I also don't know that the pollutants are going to be the main thing that's really stressing those fish out. It might be like food availability over the long term. Like, I don't know that you can really get a sustainable population without continual stocking would be my best guess.
Yeah, I think it also just boils down to the original design and management components of the system. You could design a system for water quality benefits, or you could design a system for fish and wildlife benefits. And a lot of, I think, investment has been made, particularly in Manatee County, for some of their preserves and some of their wetland restoration features to maximize the fish potential, fish factory potential. So Robinson Preserve and some of the examples I provided in my presentation, there was specific intent to create edge habitat, a mosaic of different habitats, and not just this, square in the earth filled with water. There's an intentional design that was, pursued and then constructed, and there was research done that showed, yes, if you build it, they will come. You got to build it a certain way, though.
I'll also just add, just thinking about habitat complexity, like you can design habitat for fish, but habitat complexity is going to be beneficial to the entire ecosystem. Your bugs are going to do better. There's going to be more you don't want a homogeneous, like, constant environment for the entire pond, because then that's the perfect breeding ground for like one algal species to outcompete everything. You want some variability, so there's some things that can do really well on the edge, or some things that can do really well within the littoral plants, and some things that do really well in the open water, and that's how you get more of a kind of sustainable kind of self-correcting ecosystem. And we've actually have a really good example of that on UF campus called the SEEP, the Stormwater Ecosystem Enhancement Project, that it was built in 1995, and the habitat was designed and the water levels were designed, and then they kind of walked away. And now it's kind of this like self-selecting community with really interesting habitat complexity and things. So, yeah.
All right, complexity is key to fish habitat and wildlife habitat. All right, this is my last question, and then if you'd like to come to the microphone to ask your question, please go ahead. With ponds as a stopgap for runoff, does quantity of rain diminish in wetlands and rivers? And I think that means, do ponds actually pull water from wetlands and rivers?
Stab at that. So do ponds pull water from rivers?
Does it diminish the water in wetlands? Does it dry out wetlands or rivers?
Well, I think it certainly may depend on the size of the pond and the size of the river. But if we're designing this pond correctly, there should be an attention paid to the water level range, the natural water level fluctuation of water within that area adjacent to the river or wetland. And they should be making an attempt to make sure that there's no drawdown occurring of that wetland or river. That would be your first line of defense against taking too much water, if you will. The other aspect of that, though, is the seasonality of it. It could be that that pond then stores water that can then, during the wet season, that then slowly leaks water out to the river over time through design, and that may actually be a benefit to sustain or maintain wetlands or lake or wetland or river hydroperiods, the water level fluctuation range. But I think it could be very, very situational. You know, it could be done wrong, and you could exacerbate a problem there.
Yeah. I just, sorry, this one's hotter than the other one. I just wanted to add that by like regulatory mandate, stormwater ponds are required to recreate the natural hydrology of the site. So that is like 1A with a bullet stop. That's like the bare minimum. And hydrology and stormwater designed for like water volume, and I don't mean this in a bad way or to belittle it, but it's just math. It's just math and physics. It's a lot of math. It's really hard math and really hard physics, but it's stuff that can be pretty well designed and pretty well known. And so I think unless you're grossly not doing what you say you're doing and your permits are approved and you do something different, I would not expect a pond to have an effect. Also, ponds are really only put places that the wetlands are already pulled out anyway, usually. So, like, it's maybe robbing Peter to pay Paul sometimes, too.
Yeah, I think only thing to add there is, it becomes increasingly difficult when you have a mixture of different development type, especially older development that predated some of these stormwater controls, and you have new development coming in and is seen as putting in stormwater retrofits in certain areas, but they can't really correct all those past mistakes either. So it becomes challenging to mimic the hydroperiod, and I think AJ mentioned, flashiness in the urban environment is probably one of the biggest issues of, potentially stealing that water away from natural courses. And a lot of that is based on past development practices that shouldn't be mimicked with new permitting, but there's still a lot of work that needs to be done, especially in an urban environment that was developed over the course of 50, 60 years.
And I'd like to just add to that these were designed with a certain type of precipitation pattern in mind. That was our precipitation pattern historically, but we all know, and there's been recent research to show that our precipitation patterns are changing. So we're actually getting large amounts of rain at once instead of small rain over time that leads up to a large amount, if that makes sense. So we're getting maybe the same amount of rain, but the way it comes down is totally different. And we see that, right? It's really intense rain. And so the way these things are developed were not for those intense rain rain events. They're actually developed for the less than 1 inch small rain events to work on those precipitation events. So rainfall is changing, and so will the ability of these systems to do their job. Any last questions from the audience? All right, I see a couple hands. Just go ahead and move to this microphone right here. We have time for just 2 more because we are out of time.
So first of all, Suncoast Waterkeepers, thank you all for putting on the event, and thank you to all the panelists for coming here. Jim, you made a remark I thought that stood out, made a comment. You said you'd come from the future in Pinellas County. Well, like you, I come from one future, not the. I don't believe that the county has to share that future of a fully developed county. And so my question for you is, what has been the impact, qualitative or quantitative, on the quality of life for the people in Pinellas, just from your experience?
Okay, so thanks for that. Maybe I was being a little too glib there with my comment, but I agree with you. That is a future. Continued development, business as usual. Is there an opportunity to sustain a quality of life with what we have? I guess I would say that what we see is in a highly developed urban landscape is fewer opportunities for appreciation of nature. We certainly see a greater interest by the public on finding and using parks and for recreational purposes and for studying wildlife and in that setting. Not everybody can get out and go to more of a rural setting to find a more natural or preserved landscape. So sometimes the best we have in an urban landscape is highly modified. So it becomes it's something less than what it would be otherwise, but it can be sustained, it can be maintained. I think though that generally speaking, the quality of life that remains is. I view it as texturally less interesting. That is, we have an opportunity here by preserving natural biodiversity, maintaining wetland corridors, maintaining wetland buffers, building wetlands within ponds and urban settings to hold on to some of that heritage and to maintain some of that ecological and cultural richness that we like living in Florida, that we came here to live for. You want to take a shot at it?
I think what you present at the end too is sort of the cost that we have to think about in the future as well. If we're correcting some of our mistakes now in the future, it's become more expensive, more engineered systems. There's less opportunity to do that work in the urban environment. So again, that has an economic impact as well as an environmental, aesthetic, and quality of life component for those folks living and working around those systems. So.
All right. So I'm sorry, we are out of time, and I
like to
know,
make a
Randy, you
comment.
have a question or a comment, but just give me 1 second. I do want to make an announcement, which is that there is a meeting, and hopefully you got a card. There is a Board of County Commissioners meeting on Thursday, October 5th. Hopefully that's showing. So please plan to attend. If you volunteered to to put some of what we heard today into the public record, I will send you an email so we can get on the same page with that before the October 5th meeting. Wear blue, wear your pin, show up, have your voice heard. Thank you so much for coming out today. Thank you so much for caring about our water quality. You guys are the best.